Imagine, just for a second, a future where downloading a massive, highly complex file, say an entire high-definition virtual world, takes literally no time at all. It's just there. Now, picture a world where the boundaries between virtual reality and our actual physical reality begin to completely blend together into one totally seamless experience. Think about your morning commute. Picture a scenario where cars are constantly communicating with each other, and not just with each other, but with the very roads they're driving on, way before you even see them approaching a busy intersection. Consider these sprawling, massive industrial factories that operate with almost zero human intervention, seamlessly managed top to bottom by hyper-intelligent systems. Envision a reality where artificial intelligence isn't just an app on your phone or a program on your computer, but is actually intrinsically connected to absolutely everything around you. The buildings, the transit systems, the streetlights, and most importantly, think about a world where the internet doesn't feel like a separate utility anymore. It's not something you have to actively try to connect to. Instead, it simply feels like a natural, invisible part of the physical environment itself. Well, welcome to today's Explainer. Today, we are taking a deep, cinematic dive into the developing vision behind 6G. We're going to explore the technology, the immense physical infrastructure, and the profound societal shifts that researchers and major tech companies are currently targeting. Okay, let's dive into this. The architects of our future networks are currently envisioning an infrastructure for a much, much more connected world. Because right now, let's be honest, we still think of the internet as a destination. You open your laptop, you unlock your smartphone, you consciously launch an app. You are actively crossing a bridge from the physical world into the digital world. But researchers, they are building toward a completely new paradigm. A future where you don't even realize you are using the internet simply because the connectivity is baked right into the very fabric of the room you're sitting in, the vehicle you're traveling in, and the city you're walking through. It essentially becomes as omnipresent and as invisible as the air we breathe. And that brings us to the central question of our journey today. So, what are we really looking at here? Is 6G simply a faster version of 5G? Are we literally just talking about moving from a fast highway to a slightly wider, slightly faster highway? Or could it fundamentally change what we expect from the internet altogether? It's a really critical question, because look, if 5G already provides incredibly fast mobile internet, which it does, why do we even need to spend billions upon billions of dollars researching and developing 6G? Well, the answer lies in the fact that the next generation of connectivity isn't being designed simply to make your phone download 4K videos a few seconds faster. That's not the goal. It's actually being designed to support an entirely new ecosystem of technologies that our current networks simply cannot handle at scale. Part 1. The foundation, from 1G to 5G. To really understand where we're going, we have to look at where we've been, because every single generation of mobile technology fundamentally changed what people could do with their connected devices. It was never just about a speed boost, it was about totally shifting capabilities. Generation 1, the heavy brick phones of the 80s, introduced basic mobile voice communication. And hey, that was a true breakthrough at the time. Then Generation 2 came along, brought us digital communication, and made text messaging possible at a massive global scale. Then Generation 3 arrived and made the mobile internet practical for the very first time. Suddenly, we had the web in our hands. Generation 4, that completely transformed our smartphones into powerful, always connected pocket computers. It gave us ride-sharing apps, the gig economy, and high-quality streaming video on the go. And most recently, Generation 5 introduced significantly faster connections, incredibly low latency, and the crucial ability to connect enormous numbers of devices simultaneously, setting the stage for advanced automation. The vital takeaway here is that each generation changed the types of applications developers could build, which sets us up perfectly to ask the big one: what entirely new applications will 6G unlock? Let's move to part 2 and see how this builds beyond speed, sensing, and AI. Now, what's really interesting about this is the stark contrast between our current reality and this theoretical future. Today, wireless networks are primarily designed to do one specific thing: move information. Your phone sends a packet of data, a cell tower receives it, the network routes it across the world, and another device receives that information. It is purely a communications pipeline, just getting data from point A to point B. But future 6G networks, they could potentially do so much more. Researchers are currently exploring how wireless signals themselves could be used for sensing. That means a network wouldn't just carry your text messages or emails. It could potentially help detect physical movement, estimate highly precise locations, map out physical environments, or even identify specific objects based on exactly how radio waves bounce off of them. Think about what this actually means in practice. Imagine walking into a room filled with connected devices. Today, if a smart home system wants to know you've entered that room, it has to rely on dedicated cameras or separate motion sensors, right? But in a 6G future, the invisible wireless signals that are already providing internet connectivity to that room could simultaneously act as a radar of sorts. They could provide additional real-time information about your movement and the objects around you. This integration of communication with physical sensing could create entirely new possibilities for robotics, complex industrial automation, next-gen transportation, and highly reactive smart environments. The network itself literally becomes the sensor. And honestly, you just can't talk about a network that senses its physical environment without talking about artificial intelligence. AI is an absolutely massive part of the 6G vision, because right now, networks generally follow fixed, rigid rules programmed by human engineers. But in the future, AI could be built much, much more deeply into the network itself to dynamically optimize how data moves. Picture millions of connected devices in a single, bustling city, all constantly changing their demands. Some are autonomous machines that need extremely low latency, like zero delay. Others are suddenly uploading enormous amounts of high-definition video bandwidth. Some are just tiny temperature sensors, sending a few bytes of data every hour. AI could help manage these incredibly complex, competing resources dynamically in real time. But it's totally a two-way street. The AI manages the network, sure, but 6G could in turn provide the immense, instantaneous connectivity required by increasingly distributed AI systems, basically powering the intelligence of tomorrow. To understand how that distributed AI actually works, we have to talk about something called edge computing. Let's break this down. Today, a lot of our applications depend on incredibly powerful cloud data centers. But those data centers are often located hundreds, sometimes thousands of miles away. So your device sends information to a remote server, it gets processed, and the result travels all the way back. And hey, this works remarkably well for most things. But the laws of physics still apply, and distance still matters. For applications that require extremely fast, split-second responses, sending information to a distant cloud introduces unwanted delay, even if it's just a fraction of a second. Edge computing solves this by moving some of that heavy computation closer to the user or the device, literally putting servers at the edge of the network, like at the base of a cell tower. 6G could connect these distributed computing resources instantly, drastically reducing the physical distance data needs to travel. And that matters immensely when mere milliseconds can literally make the difference between a car making a safe stop and a severe collision. And this brilliantly illustrates our next point. Part 3, connecting the physical world. Let's look closely at autonomous vehicles for a second. Self-driving technology is already here, but it heavily relies on a vehicle's onboard cameras, its own radar, and its own internal computers. But think about an autonomous vehicle approaching a really complicated, incredibly busy blind intersection. With 6G edge computing and ultra-low latency, the car doesn't just have to rely on what its cameras can physically see. It can communicate with nearby infrastructure, with the other vehicles on the road, and with centralized traffic systems, all simultaneously. So a car could potentially receive highly accurate information about hazardous road conditions or an approaching emergency vehicle blowing a red light long before its own physical sensors could ever detect them. Now, it doesn't mean 6G automatically creates fully autonomous transportation overnight, but this faster, much more reliable communication becomes a critical, foundational piece of a vastly safer transportation system. Now take that concept and expand it. Zoom out from just one single vehicle to an entire interconnected city. We are looking at the true realization of smart cities. With the sheer bandwidth and massive device capacity envisioned for 6G, office buildings could communicate directly with public transit systems to optimize commuter flows during rush hour. Traffic signals wouldn't just run on timers, they could adapt instantly to real-time traffic and pedestrian conditions. Energy systems and power grids could respond instantly to surges in demand across different neighborhoods. Sensors embedded in concrete could constantly monitor the structural health of bridges and roads to prevent collapses. Public services could become far more automated, with delivery or sanitation robots seamlessly navigating shared human environments. 5G is already pushing us in this direction for sure, but 6G could be the spark that turns the city itself into one massive, living, breathing network of connected systems. And this high-speed, edge-computed environment also unlocks what many consider the next frontier of personal computing, extended reality, or XR. We know virtual and augmented reality already exist, but current devices have some pretty major limitations. They can be really bulky, they require powerful internal hardware, they get hot, they can be uncomfortable for long periods, they chew through massive amounts of data, and quite frankly, any lag or latency can completely ruin the immersive experience, or even make you dizzy. But future 6G networks could support much, much more demanding applications. Envision lightweight, stylish, everyday glasses that are continuously receiving immense amounts of information from the network. Because all the heavy computing power is happening remotely at the edge, the glasses themselves can stay incredibly light. They could flawlessly overlay high-definition digital information right onto the physical world. A mechanic could see step-by-step digital instructions overlaid directly onto a complex airplane engine as they repair it. A student could walk through a perfect digital recreation of a historical environment without ever leaving their physical classroom. A surgeon could interact with highly detailed, real-time remote medical visualizations while consulting with an expert across the globe. So the crucial point is, this incredible volume of real-time data also allows for the creation of something absolutely fascinating called a digital twin. A digital twin is exactly what it sounds like. It's a continuously updated virtual representation of a physical object, a system, or even an entire environment, fed entirely by real-time sensor data. Imagine a massive automotive factory with thousands of moving machines. Sensors are continuously collecting granular information on temperature, vibration, and output, feeding that data directly into a digital 3D representation of the factory. AI is constantly analyzing this data in the background. If the digital twin detects that one physical machine is beginning to vibrate just a fraction of a millimeter more than it should, behaving even slightly abnormally, the system could potentially identify the problem and automatically order maintenance before the physical machine actually fails and halts production. Now, just apply that exact same concept to an entire city's energy network or a country's transportation grid. High-capacity 6G connectivity would be absolutely critical for making these vast, constantly updated digital mirrors practical at scale. Within this massive 6G ecosystem, we also see revolutionary applications for robotics and true global reach. Consider a massive logistics warehouse containing thousands of automated robots that need to coordinate movement, avoid collisions, and adapt to unexpected situations on the fly. A highly connected network becomes the invisible infrastructure, allowing them to work together as a perfectly unified swarm. But it's not just about what happens on the ground here on Earth. A major possibility for 6G is much deeper integration between our terrestrial cell networks and satellites up in space. Today, your cell service and satellite networks often operate as entirely separate, distinct systems. Future connectivity could totally blur this boundary, utilizing low Earth orbit satellites to provide seamless coverage in incredibly remote areas. This means keeping aircraft and ships connected across oceans and bringing much-needed high-speed access to rural communities that have been historically left out. It also means that emergency services could maintain critical communication even when ground-level terrestrial towers are completely knocked out by natural disasters, making global connectivity vastly more resilient. Part 4. The hidden costs: security, privacy, and reality. Because it's not all just a high-tech utopia. First, we need a vital dose of caution. Whenever we talk about 6G, we are talking about the early 2030s for the targeted initial commercial deployment, at least according to most current industry roadmaps. The exact specifications, the technical capabilities, and the commercial implementations of 6G are not yet fixed. They are still actively being researched, debated, and standardized by engineers worldwide. That means we absolutely must think of 6G as a developing technology with incredibly ambitious goals, rather than something that is already finalized with guaranteed features. Some of what we've discussed today might actually arrive gradually through incremental 5G improvements, while other aspects will absolutely require entirely new infrastructure built from the ground up. And speaking of building that infrastructure, that brings us to one of the absolute biggest technical challenges: spectrum. All wireless communication fundamentally depends on radio frequencies, and usable spectrum is a highly limited natural resource. To get the massive, mind-boggling bandwidth that 6G promises, researchers are exploring much higher frequency spectrums than we use today. But here is the stark physical reality of radio waves. While higher frequencies can carry enormous amounts of data, the signals themselves have incredible difficulty traveling long distances. They are very easily affected and, frankly, blocked by everyday physical obstacles. We're talking walls, trees, buildings, and even atmospheric conditions like heavy rain can degrade the signal. This means future networks cannot simply rely on the traditional, widely spaced, large cell towers we're used to using today. Because those high-frequency signals are so fragile and short-range, the network will require an incredibly dense combination of different access points and highly intelligent routing systems. And that brings us to the unavoidable financial reality. Creating a completely new generation of wireless infrastructure will not be cheap. We are talking about constructing entirely new towers and millions of intelligent, localized access points, laying down extensive new underground fiber optic connections across the globe.
building out the localized data centers and that distributed edge computing infrastructure we talked about earlier, procuring entirely new spectrum, securing the immense new sources of electrical energy required to power it all, and developing highly advanced semiconductors, complex software, and robust security systems, all to support billions upon billions of new connected devices. When you add it all up, the sheer physical footprint and the financial cost of this endeavor is just staggering. Which naturally leads us to a really critical societal question that researchers are asking. With such immense costs involved, will 6G actually make the digital divide smaller? Or will it inadvertently create yet another massive gap between wealthy countries capable of building out this expensive, advanced infrastructure and developing nations that might really struggle to afford it? Developing countries could face entirely different, much steeper challenges in deploying these dense, high-frequency networks. Ideally, the goal of future connectivity should be to expand human access globally, bringing everyone forward, rather than simply making already connected, wealthy regions vastly more advanced while leaving others further and further behind.
And beyond physical access, there is the deeply, deeply complicated issue of privacy in a hyper-connected world. Because think about it, if we achieve a network capable of actively sensing physical environments, collecting enormous amounts of data to build perfect digital twins, and connecting everyday physical objects, privacy becomes a massive, unavoidable concern. If a network intimately understands exactly where specific devices are located, how people physically move through a room, and what machines are doing at all times, the questions just pile up quickly, don't they? Who actually owns that granular, highly personal information? Who gets to access it? How long is it stored on those edge servers? Can it be utilized by companies for hyper-targeted advertising? Can governments demand unrestricted access to it? Can private companies just freely sell it to the highest bidder? These questions regarding basic data rights may become just as important, if not more so, than the technical engineering capabilities of 6G itself. And completely intertwined with privacy is the undeniable critical threat to cybersecurity. Greater connectivity inherently creates greater risk. There's just no way around it. When enormous numbers of physical devices become connected to the wider network, the attack surface expands exponentially. Today, a compromised smartphone or a hacked laptop is a major personal problem. It's a headache. But in a 6G future, a compromised, heavy industrial robot in a factory is an entirely different threat level. A compromised autonomous vehicle traveling at 70 miles per hour on a busy highway could be absolutely disastrous. A vulnerable smart energy system could severely affect the safety and infrastructure of entire communities. Security absolutely cannot be an afterthought here. Future networks will require unprecedented levels of authentication, quantum-resistant encryption, and real-time anomaly detection. And while AI will absolutely be used to defend the network, AI will also certainly be used by attackers to probe for weaknesses, creating a perpetual, highly complex, and high-stakes technological arms race. Now, with all this intense talk of ubiquitous 6G coverage everywhere you go, a very common question usually arises. Wait, will 6G just replace Wi-Fi entirely? Should I throw out my router? Well, the answer is not necessarily. The future of connectivity really isn't about one single technology coming in and ruling them all. It will likely involve multiple different types of connectivity working seamlessly together in the background. Wi-Fi will undoubtedly continue to provide high-speed, dedicated local connections in our homes and our offices. Cellular networks, like 6G, will provide wide-area, intelligent connectivity and high-speed mobility when we're on the move. And satellites will provide that crucial safety net coverage in remote places. The ultimate goal isn't to eliminate Wi-Fi, but to make the transition between these different technologies utterly invisible. The goal is to make connectivity feel entirely continuous to you, the user, no matter where you go or what device you are using. So, to wrap up our deep dive today, we return to the question that started it all. Could 6G change the internet forever? Well, the biggest mistake we can make would be thinking of 6G as simply 5G, but a little bit faster. If 6G only allows people to download large files quicker, its impact will be purely incremental. It'll be convenient, but not revolutionary. But the true promise, the deeper, much more ambitious vision, is an integrated ecosystem connecting communication, edge computing, environmental sensing, AI, advanced robotics, autonomous transportation, and immersive XR experiences. Think about it. The internet originally began as a way to just connect computers. Then, with mobile devices, it evolved to connect people. The next generation aims to connect the physical world itself.
If this massive vision is actually realized, 6G won't just feel like another routine network upgrade. It may genuinely feel like the pivotal moment the internet stopped being a tool we consciously decide to use and instead became the invisible, intelligent foundation that the physical world itself runs on. Thank you for joining us for this explainer. What part of this hyper-connected future are you most looking forward to, or perhaps most concerned about?